So we're going to look at the May 2021 Danish afgangsprøve, the school leaving exam for 15-16-year-olds, and it's the 1 hour paper. So that's the paper that consists of 50 short questions, no calculators, no books allowed. First section, number and algebra. Exercise 1. The sign shows prices from a baker. So there's different kinds of bread and cakes and rolls. 30, 15 and 5 kroner. Then there's an offer. 4 jordbærkær, 50 kroner. 4 strawberry tarts for 50 kroner. And then 4 styk morgenbrød for 15 kroner. 4 rolls for 15 kroner. So it says, how much does 1 hvedebrød, like a white loaf, and 2 jordbærkær, 2 strawberry cakes, strawberry tarts, how much does that cost in total? So let's just get my pen up. Okay, so we're looking at 1 white bread and 2 strawberry cakes, 15, 15, 30 plus 15 plus 15, 60 kroner, straightforward. How much do you save by buying 4 strawberry tarts on offer instead of buying 4 at the normal price? Okay, so 4 on offer is 50 kroner. 4 at the normal price is 4 times 15, which is 60. So 60 minus 50 means you save 10 kroner. Then it says, how many percent do you save by buying 4 rolls instead of 4 rolls on offer instead of 4 at the normal price? So it's the same as the last question really, but it's about the rolls. So 4 cost 15, but 4 at normal price costs 5 kroner each. 5 times 4 is 20. So it's 20 minus 15. You save 5 kroner. But the question is, how many percent? So it's 5 kroner out of the original price as a percent. Now, when you're working out how much you're saving or how much is changing, it's always got to be out of the amount that it's changing from. So you're saving 5 out of an original 20 kroner. You're saving 5/20ths of the original price. You want that as a percentage, which is out of 100. So you need to multiply it by 100 on the top. So the percentage that you save is 5 on the top over 20 on the bottom times 100 on the top. So that's 500 over 20. Having a bit of trouble with my pen here. Percent. 500 divided by 20, 50 divided by 2, it's 25%. So you are saving 25% out of the original price that you would have paid, and it's got to be calculated out of the original price. That's what you're comparing it to. Okay, exercise 2. Well, there have been a lot of questions like this in these exams around this time, where you have a recipe for something and then you're asked about different quantities of stuff. So you've got muffins. You've got a recipe for 12 muffins, and it's got ingredients: 2 eggs, 1 3/4 deciliter sugar, 1 I can never remember whether that's a teaspoon or a tablespoon vanilla sugar, 3.5 deciliters of flour, 2 spoons of baking powder, 125 grams of butter, 2 bananas, 100 grams chocolate. Okay, how many eggs does Isabel need to use if she wants to bake 36 muffins? So the recipe is for 12 muffins. 12 times 3 makes 36. So she's got to take the 2 eggs there and multiply it by 3 and have 6 eggs. How many deciliters of sugar does Isabel need to bake 48 muffins. Well, again, the recipe's for 12 muffins. 12 times 4 makes 48, so she's got to use 4 times as much. So we've got 1 3/4 times 4. So let's just remind ourselves how multiplying fractions works. Let's just take that over there. So the way I like to do these, make the fraction top heavy. So 1 3/4 is 7/4. 4 times 1 is 4 plus the 3 makes 7. So we've got to do 7/4 times 4, and then times 4 and dividing by 4 cancel each other out, so that without having to do any other calculation is 7. So 1 3/4 times 4, which is 7. Okay, question 2.3. How many muffins can Isabel bake at most? Excuse me. If she has 7 deciliters of flour. Okay, well, at the moment, the recipe she's got is involving 3.5 deciliters of flour. Hopefully you can spot straight away that 3.5 times 2 gives you exactly 7, so she can bake 2 times as many as the recipe. So 2 times 12, 24 muffins, assuming she has all the other ingredients, of course. Okay, on to question 3. Noah runs 1 kilometer in 6 minutes. What is Noah's average speed in kilometers per hour? Okay, so if he can run 1 kilometer in 6 minutes, then he can run 1/6 of a kilometer in 1 minute, and he can run 60 times that, 66ths of a kilometer in 1 hour. I'm writing this half Danish and half English, i en time. So 60/60ths of a kilometer in 1 hour, because 1 hour is 60 minutes, so 60 times as much. 60 over 6 is 10, so he can run 10 kilometers in 1 hour. Again, mixing my Danish and English. So his average speed is 10 kilometers per hour, because that's what he can run at that rate in 1 hour. Just tidy up there. Okay. Isabel runs 12 kilometers in 1 hour. How many minutes does Isabel take to run 12 kilometers? Okay, so 12 kilometers per en time, in 1 hour. So in minutes, because we're trying to calculate this in minutes, so that would be 12 kilometers in 60 minutes. An hour is 60 minutes. So 1 kilometer would take 1/12 as long. So you've got to do 60 divided by 12, which is 5. 1 kilometer would take 5 minutes. Let's fill in 5 minutes. So on to question 4. Noah has made 12 litres of Hjælpemidler, which is this sort of cloudy apple juice, which he's filling bottles with. There can be 3/4 of a litre in each bottle. How many bottles of cloudy apple juice can Noah fill? So he's got 12 litres. Just get that on. And he's dividing it into bottles that are 3/4 of a litre each. So the number of bottles is going to be 12 divided by 3/4. In fact, I think I'll just do the top 2 dots for divide, follow the Danish convention. So you've got to do 12 divided by 3/4. Excuse my cough. So when you're dividing by fraction, one good trick is to change it to a multiply and flip over the thing you're dividing by. So 12 divided by 3/4 is the same as 12 times 4/3. Easy little trick you can remember. You just got to remember you only flip over the one you're dividing by, not everything. So it's the same as 12 times 4/3, which is just 12 times 4 on the top divided by 3 on the bottom. So it's just 48 divided by 3, which is 16. So you can fill 16 bottles. Okay, get rid of some of the mess here. Noah gives Isabel 4 bottles of Erblemost. How many litres has Noah given to Isabel? Okay, so each bottle is 3/4 of a litre. He's given her 4 bottles, so she gets 3/4 times 4. So that's just 3 on the top divided by 4 on the bottom times 4 on the top. Well, it's easy to see that the times 4 and divide by 4 cancel each other out. So that's just going to be 3. She gets 3 litres. Next one. 6 friends share one of Noah's bottles of cloudy apple juice. How much do they each get if they each get as much as each other? If they each get equally much. Okay, so you've got 3/4 of a litre, which is one of the bottles, and you're dividing that by, let's use the 2 dots for divide, and you're dividing that by 6 people. So you've got to do 3/4 divided by 6. Well, a couple of ways you could look at it. You could think of, let me just undo that a bit. You can think of 6 as being 6/1. So you're doing 3/4 divided by 6/1, and then you can do the thing about changing it to a multiply and flipping it over. So that's the same as 3/4 times 1/6, which would be top times top, bottom times bottom. 3 times 1 is 3. 4 times 6 is 24. So they'd get 3/24 of a litre, which is the same as 1/8 of a litre, or if you prefer 0.125 of a litre. Okay, so that's one way you could do that. Another way, I guess you could say 3/4 of a litre divided by 6. Well, the line in a fraction means divide, so if you're dividing by 6, it's just the same as having times 6 on the bottom, and you kind of get to the same place. Okay, next block of questions, just some straightforward arithmetic. I'm not going to do much explaining here. I'm just going to kind of do these. So 2, 3, 4, 5 plus 9, 9, 7. I mean, you could do something smart with recognizing that that's near to 1,000, and then doing a quick calculation that involves adding 1,000 and taking off 3. I'll do it the long way. So 5 plus 7 is 12, 2 carry 1. 4 plus 9 is 13, plus the 1 I carried makes 14, 4 carry 1. 3 plus 9 is 12, plus the 1 makes 13, carry the 1, 1 plus 2 is 3. 3, 3, 4, 2. 3, 3, 4, 2. But I might more quickly in my head have just taken that, added 1,000, and then taken off 3. Half the battle with these is just getting the right, spotting whether it's a plus, minus, divide or multiply. It's amazing how many people manage to get that wrong. 1302 minus 298. So you could do something clever with taking off 300 instead of 298, then adding on the 2. But I'm going to do this the long way. So 2 minus 8 can't go, borrow 1. 12 minus 8 is 4. Pay the 1 back. Borrow from there. 10 minus 10 is 0. 3 minus 2 is 1. 1 minus nothing is 1. 1, 1, 0, 4. 1, 1, 0, 4. Then we've got 11 times 72 I'm actually going to flip that round and do 72 times 11, because then I can very easily do 1 times 72 and 10 times 72, giving me 792. 792. And then 2008 divided by 4. Let's just clear up some of the mess here. Okay. 2008 divided by 4. Okay, so 4 doesn't go into 2, so nothing. Carry the 2. Carry the 2. 4 goes into 25 times with nothing left over. 4 goes into 0, no times. 4 goes into 8, 2 times. 502. And you might have spotted that it's quite easy to just halve 2008 and halve it again in your head to get divided by 4. Okay, good old algebra. 4x plus 5 equals 21. I'd like to get the bit with x on its own, so I'd like the 5 to disappear. So I'm going to take away 5, but I've got to remember to do that both sides. So 4x equals 16. I just want to know what 1x is, so I'll divide everything by 4. X equals 4. Next one. Let's just make myself a bit of space here. Delete that. Okay. 5x equals 3 brackets x plus 4. Well, let's multiply those brackets out, get rid of those. So 3 times everything in the bracket. 3 times x is 3x, 3 times 4 is 12. So 5x equals 3x plus 12. We've got x's on both sides. I don't want that, so I'll take away as much x as I can from both sides. So the most I can take from both sides is 3x's. So I'm going to take away 3x's from the right, and then the 3x's disappear, and I've just got the 12. But then I've got to take away 3x's from the left as well. So 2x equals 12. I want to know what a single x is, so I'll divide everything by 2 to get a single x equals 6. Okay, let's do the next one. Delete all that. So 12 over x plus 3 equals 7. I'd like to get the bit with x on its own, so I'm going to take away the 3, and then it'll disappear, but I've got to take away 3 from the other side. So taking away 3 from both sides, 12 over x equals 4. I'd like to get rid of that fraction, so I'm going to get rid of that fraction by multiplying by the denominator. So if I multiply everything by x, then I'll just have 12 on the left, because the times x and the divide by x in the fraction will cancel each other out. But to keep the equation balanced, I've got to multiply the other side by x as well. So multiplying both sides by x, 12 is equal to 4x. Well, I want to know what 1x is, so I'll divide everything by 4 both sides. 3 is equal to x. X equals 3. Few things with decimals and fractions. Write a decimal that is twice as big as 0.7. That's 1.4. I'm not going to go to great lengths to explain why. Write a fraction that is half as big as 4/7. That's going to be 2/7. Write 3/8 as a decimal. So 3/8 is 3 divided by 8. So let's try and do that. Let's stick some extra zeros in there. So 8 doesn't go into 3. It goes no times. Carry the 3. 8 goes into 30. How many times? 3 times. 3/8 make 24, so there's 6 left over. 8 goes into 60. How many times? 6 8s are 48. 7 8s are 56. It goes 7 times. 7 8s are 56, so there's 4 left over. And then 8 goes into 40 5 times with nothing left over. So 0.375. Okay, a few things about doing calculations in the right order. So 8 minus 2 times 3. That dot means multiply in Danish. So you've got to know to do the multiplying first. So that's the same as 8 minus 6, which is 2. So that's that one. 0.6 minus 1. So you've got a small thing minus a bigger thing. This has been quite a popular question. The way I do this in my head is just to flip it round. So 1 minus 0.6 is quite easy to do in your head. It's 0.4. And then just flipping it around as 0.6 minus 1. So wherever there was a plus, there's a minus. Wherever there was a minus, there's a plus. It's just going to be the negative of that. 0.6 minus 1 is minus 0.4. So good little trick where you've got something like that. Easy to just flip it round in your head and then flip the minus to a plus. Okay, minus 2 squared plus 3 squared. So minus 2 squared means minus 2 times minus 2. And 3 squared means 3 times 3. Minus 2 times minus 2 is 4. Minus times minus makes plus. 3 times 3 is 9. So it's 4 plus 9, 13. Okay, straight line equations. So you've got a straight line, and then what is the equation that describes it? So generally speaking, a straight line is going to be in the form y equals something x plus c, usually referred to as mx plus c. A little bit confusing there because they've called the line m, but we'll ignore that for the minute. And then the number in front of x is what's called helning in Danish, the gradient, and it's how steep the graph is. And the plus something on the end is the intercept, or skæringspunkt in Danish. It's where it cuts the y-axis. So on this particular occasion, just get rid of all of that. The intercept is 4 because it cuts at 4, and then the gradient is minus 2 because for every 1 across, the graph goes down by 2. 1 across, 2 down, 1 across, 2 down. It's got that constant slope that for every 1 across, it goes 2 down. So the equation of the line is y equals minus 2x plus 4. The number on the end always tells you where it cuts. The number in front of x always tells you how steep it is, the gradient or the helning in Danish. So the question, which equation describes line M? So it's y equals minus 2x plus 4, which is that one. Okay, exercise 10. Well, this has been a popular question over the years. You've got some kind of shape that's kind of rectangles stuck together, or overlapping rectangles, or different squares and rectangles forming a weird shape. So it says the shape shows an octagon with side lengths A and B. So that might not be the first kind of shape that comes to mind when you think of the word octagon, because you probably think of a more regular octagon, drawn better than that, I hope. But it's got 8 straight edges and it's a contained shape, so it is by definition an octagon. So first of all, you've got to work out the omkreds, which is the perimeter of the octagon, so the distance all the way around, in other words. So you've got an A, a B, and a B, an A, an A, and a B, and an A, and a B, and a B. So you've got 4 A's and 4 B's. 4A plus 4B. Then they're asking for the area of the shape. So octagon, as they like to call it. It still feels a bit weird calling it an octagon, but it is an octagon. So you just need to kind of figure out a way to break the shape up. So you might for example, think of it as a rectangle at the top, a square in there, and a smaller rectangle at the side. So the rectangle at the top is clearly A times B, A times B, AB. The big square is clearly A times A squared. Then you've got this bit here, so it's B at the bottom, you can see that, but down the side, well, it's not A because A is the whole square. We've only got a bit of it. We've got A minus B. So the area of that bit is A minus B multiplied by B, which is, if you multiply it out, A times B is AB, minus B times B is minus B squared. So the area of the whole thing is A squared plus AB plus another AB minus B squared. So A squared plus 2 ABs minus B squared. If I can just get this pen to work. And of course there will be various ways you could have chopped that up. So instead of chopping it up that way, I might have chosen to kind of do something down there and worked out 1, 2, 3 rectangles like that. But if I do it correctly, once it boils down and I've simplified the algebra, I should end up with the same expression, A squared plus 2AB minus B squared. Okay, geometry and measurement. So you've got your good old question where you're converting units of things. 7.5 kilograms in grams. Kilo usually refers to 1,000. A gram is smaller, so there's going to be 1,000 times as many grams as the kilogram number. So 7.5 times 1,000 is 7,500. Millimeters into centimetre. So millimeters are smaller, centimetres are bigger, so there's going to be fewer centimetres because they're bigger. 10 millimetres in a centimetre, so you've got to divide the number by 10. 211. And then 36 hours is how many, well, that's days, as in 24-hour days. So how many lots of 24 hours is there in 36 hours? Well, hopefully you can kind of see it's a day plus a half a day, 24 plus 12 hours. So it's 1.5 days. Days being a 24-hour day, not daylight days. Okay, question or exercise 12. The drawing shows a triangle and then lines A, B, C, D, and E. So each of these lines A, B, C, D, E is labelled. So those letters refer to lines. Put one X in each row. Which line is one of the triangle's heights? So Hoyda heights, the height of the triangle. So if you're working out the area of the triangle as half times base times height, then which one of those lines is one of the lines that you could use as the height of the triangle for that? So the height means perpendicular to the ground from the bottom to the top. So for example, if that was the triangle, the height would be that because it's 90 degrees to the ground straight up to the top of the triangle. So that's A. A is it goes from the bottom of the triangle to the top of the triangle and it's 90 degrees to the ground. It doesn't matter that it's outside of the triangle. It follows the criteria you need for it to be a height of the triangle. So that's A. And then which line is one of the triangle's medians? So a median is a line that goes through the center of one side to one of the vertices or one of the points on the other side. So I'm just trying to justify the idea that B isn't that. It kind of doesn't look right. But is there anything that tells me for certain that it is D? That's interesting. I am going to go for D with some hesitation, because it sort of looks like it could be B as well if B cut through the middle there, and it looks very much like it's not in the middle, whereas D is in the middle. Although I'm very cautious, because exam questions are famously not drawn to scale when you have diagrams. So I'll go for D with some caution on that one. Okay, question 13, quite a popular question in recent years. It says, on the sketch below are the lines A, B, and D, E are parallel. That is parallel to that. A, B, and D, E are parallel. Triangles A, B, C, so that's the little triangle, and triangles D, E, C, the big triangle, are they're similar. They're similar, which means they're the same basic shape. All the angles are the same in both shapes. The sides are in the same ratio correspondingly to one another. So they're the same basic shape, just different sizes. Then it says the length ratio between triangle ABC and triangle DEC is 1:4. So it's just saying that all of the lengths are 4 times as big in the big triangle compared to the small triangle. So for example, where that's 5 there, just trying to get the old pen to work here, where that's, doesn't want to work. Where that's 5, why doesn't that work? Try again. Well, there we go. Where that's 5, that'll be 20 in the big triangle. 4 times as much. So that answers our first question. The length of side DE is 20. Then the next question is, the length of side CE is what? So the length of side C to E, they're asking us. Well, they've already told us that from B to E is 12. And we know that from C to E is 4 times as big as from C to B, because they're in the ratio 1:4. I mean, it doesn't look like it's 4 times as big, but this is, after all, just a sketch. If this was an English exam, it would say diagrams are not drawn to scale. They always do wonky diagrams in exams so that you don't get the answer just by measuring it. Okay, so I'm going to look at it this way. I'm going to split this line that I'm trying to find out into CB plus BE. So down the side here, we've got CB plus BE, and I know that that is 4 times as big as CB on its own, because everything in the big triangle is 4 times as big as everything in the small triangle. Well, I know what BE is. It's 12. So CB plus BE equals 4 lots of CB. If I take one of the CBs away from both sides, sorry, I just wrote the same thing again, didn't I? CB plus 12, I meant to say, is 4 times, this pen's useless, 4 times CB. Yeah, so if I take one of the CBs away from both sides, I get 12 on its own is equal to 3 CBs. And if I divide everything by 3, I get 4 is equal to CB on its own. So that tells me that 4 is equal to CB. And then the whole thing is 4 plus 12, which is 16. So the whole thing is 16. And it all checks out that 16 is 4 times as big as the 4, which we would expect it to be. So the question was the length of the side CE, which is the 16. Okay, and then finally, the same tricky question that's occurred in exam after exam after exam on this topic. The area of the triangle is how many times as big as the area of the small triangle. So how many times as big is the area of the big triangle compared to the small triangle? Now, classic mistake would be to think that it's 4 times as big because the lengths are in the ratio 1 to 4. But area consists of 2 dimensions, so it's 4 times as big lengthwise, but it's also 4 times as big.
Sorry, I don't have an answer for that.
My Alexa's just gone off. 4 times as big height-wise. I wonder what triggered that. So it's actually going to be 16 times as big because it's 4 times 4 times as big. Another way to think of that is how many of the small triangles could you fit into the big triangle? So if you can fit 4 in height-wise, again, it doesn't look like it because it's a wonky diagram, and then 4 times as many in lengthwise, then you start filling them in. Boom, 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 boom. Wonky because it's a wonky diagram, but you can fit 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 of them in, which would be the same as one another if the diagram wasn't wonky in the first place. But length area 1 to 4, or length ratio 1 to 4, area ratio 1 squared to 4 squared, which is 1 to 16, so it's 16 times as much. Okay, moving on to exercise 14. Noah's father has got to lay some tiles for a terrace. The terrace has to be rectangular with side lengths 5 meters and 3.5 meters. The tiles are also rectangular with side lengths of 1 and 0.5 meters. How big is the area of the terrace? So that's just asking you to do 5 times 3.5. So let's just do that. I'll just do it as if it were 35 times 5. That's probably the easiest way to think about it. Knock out the decimals, which is 175. So 35 times 5 is 175. 3.5 times 5 is going to be 17.5. How many tiles does Noah's father need to use for the terrace? Well, I mean, they've helped you a bit with the drawing, but if the tiles are each 1 by 0.5, it makes sense to have the 0.5s in the bit where you've got an odd 4.5. So how many 4.5? 3.5. So how many 0.5s do you need to fill out the 3.5? The answer is 7. You can either do 3.5 divided by half, or you can literally just count 0.5s on your fingers. 0.51, 1.52, 2.53, 3. So on. Excuse my cough. So you get 7 of them. And then how many ones do you need to make up 5? You need 5 of them. So it's going to be 5 tiles by 7 tiles, 35 tiles. Go on. Okay, another popular question over the years, an unfolded net. So the drawing shows the net of a prism. You can calculate the volume of a prism by the formula in the yellow box. Okay, well, let's just kind of imagine this folded up. So it would be a right-angled triangle at 2 ends and then kind of joined up to make the prism. And the volume of a prism is just the end area multiplied by the length throughout which it's extended. So just to be clear, let's just try and draw this one a little bit better. In fact, I've probably got some nice drawing tools I can use for this, haven't I? I've got a... I can't believe I haven't got a... Oh, there it is. No, I don't have a nice right-angled triangle. That's surprising. Okay, never mind. So let's just try and do this a little bit better by hand. In fact, I wonder if I can copy paste that. Copy, paste, there we go. So it's got a triangle at the front, a triangle at the back, and it's joined up. Like that, and like that. And I wonder if I can do a dotted one. Yeah, lovely. There we go, and a dotted one at the back you can't see. So a prism is a shape that's kind of got the same at the front, the same at the back, and if you slice it somewhere along the middle, it'll be the same there. And the volume of a prism is whatever the end area happens to be, multiplied by the length that's stretched throughout. So if we can imagine this thing folded up, it would be 10 lengthwise, it would be 3 at the bottom, 4 at the base, 5 down there. The area of a triangle is half times base times height. So the area of that triangle would be a half times the base of 3. What's happened there? Times the base of 3 times the height, which is 4. And in fact, the 5 is a bit of a red herring in this calculation. It's irrelevant. So the end area is a half times 3 times 4, which is 6. So the area of the triangle on the end is 6. So the volume of the prism is the end area of 6. I wonder if I can write that in a different... There we are, 6. Multiplied by the 10 that it's stretched throughout. So that would be 60. And then we want the prism's surface area. So we already figured out that the triangles were 6. This rectangle here is 10 times 4, which is 40. This side of 3 here folds to this side of 3 here. So that's going to be 3 there. So it's 10 times 3, which is 30. And then this side here folds to the 5 there. So that's going to be 5 times 10, which is 50. So the total surface area is, so you've got 2 6s on the ends, you've got a 40 on the side, you've got a 50 at the back, and you've got a 30 underneath. So just add all those up. 40 plus 50 plus 30 is 120, plus the 2 6s makes 132. Okay, exercise 16. The sketch shows a trapezium, not drawn to scale, so don't go trying to measure any of the angles. The dotted line stands at, is right angled to the parallel sides of the trapezium. So the trapezium's got 2 parallel sides. That's what makes it a trapezium. And the dotted line is at 90 degrees, right angled to that. Okay, so let's try and fill in some information here. So we've got 90 there. It's going to be on a straight line with a 90 there. I've got a triangle here with 90 and 60, so it's got to be 30 for the last side to make it add up to 180 for a triangle. So this whole thing here is 120 because it's 90 plus 30. What else have we got? we want to work out angle V. So we can either do it from the big four-sided shape with 60 and 80 and 120, and then subtract those all from 360, or we could do it with the smaller four-sided shape to the left of the dotted line. Well, I feel like doing it with the 60, the 80, the 120 and that. So 60 plus 80 plus 120 comes to 260. A four-sided shape has got to add up to 360. So 360 minus 260 means that's got to be 100. So angle V is 100. Oh, and they're asking us to figure out angle U. Well, angle U is on a straight line with that 30 that I figured out before. So it's got to be 180 minus 30, which is going to be 150. Moving on. Which drawing does not show a reflection of a triangle in a line? Okay, so in a reflection, if you join the corresponding points like that, then the lines you draw should cross the mirror line at 90 degrees, which makes sense. You know, if you're standing there and you look at yourself in the mirror, you expect to see yourself directly ahead and the same distance away. So any kind of a reflection, if you join corresponding points, then they should cross the mirror line at 90 degrees and be the same distance away from the mirror line. So if we try and imagine that, so this one looks a bit wonky because you can see that point there is not the same distance to the mirror line when you join up the corresponding points. Yeah, so if I'm standing here and I look in the mirror here, I expect to see myself the same distance away. I'm a little bit alarmed if I see myself all the way down there. So all of the others seem to check out with everything. If you join up the points being the same distance away from the mirror line and crossing the mirror line at 90 degrees. But D is a bit wonky. So D is the wrong one. Okay, probability and statistics. That's always giving me an idea that I'm near the end of the paper, thank goodness. So exercise 18. The diagram below shows how many tons of plastic waste from Danish households have been genanvendt. Is that recycled? Not sure. In the years 2011 to 2017. Question 18.1. How many tons in the year 2016? So that's just kind of reading off. So 15,000, bit more than 15,000. I mean, I would say it's certainly not another whole 1,000 up if you imagine that being divided into, yeah, not entirely sure. That looks like it's kind of 1/10 of the way up that scale, so I would say that's about 15,500. I'm wondering how much leeway there is for error on that question. And that could depend on the actual person marking it, because it's marked typically in schools by people who aren't provided with a standard set of answers. They do the papers themselves and then they agree with someone from the school. So that could be a bit down to luck of the interpretation of the person marking it as to how far that goes up. Or, they might just get a ruler out and be a bit more rigorous and figure it out more clearly. Anyway, about how many more tons in 2017 than in 2011? So in 2017, well, I'm going to call that looks like 19,500 to me. 2011, that looks like, I would say 6,000, 6,500 maybe, no, 5,500. So minus 5,500. So I'm going to say that's approximately 14,000 more. So I'm saying that is 14,000 more than that. Again, could be a little bit down to the individual person's interpretation of the graph. Looking at it again, I'm thinking that the gap there to the line is a bit bigger than the gap there to the line, so maybe that's supposed to be a whole 1,000. So in fact, I'm going to revise my answer and say 19,500 minus 6,000, 13,500. And I mean, in fact, because it does say approximately 13,500, approximately, you would hope there is some leeway for error in the that the person marking it would give you. But again, there's not always that much guidance and consistency about that, unfortunately. Okay, exercise 19. Pupils in 9A have told how many hours they've used for voluntary work in a particular week. The table shows the class's data set. So 0 hours, 9 people said they did 0 hours, 1 person they did 4 hours, and so on. The data set's highest value is what? So there was 1 person who did 7 hours, so it's 7 hours. The data set's two-per-tail, that's the mode, that's the number of hours that most people did. And you can see that there were 9 people that did 0 hours. So 0 hours is the most popular value. And then the data set's median. So if you line all the pupils up in a row, who would be standing in the middle? I mean, you can take a very primitive approach to this and just write them all out. But I'm not going to do that. I'm going to do it the proper way. Then I might just write all them out afterwards, but let's see. Okay, so there are 9, 13, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 pupils in this class. So 25 pupils. And then the middle person is the 25 plus 1 divided by tooth value, D in Danish, value. So the 13th value, the median is the number of hours that the 13th person did. So if you stand them all in a line, the 13th person is the middle one. So it's always how many you've got plus 1 divided by 2. That's the value you're looking for. In that case, that's the 13th one. So you can see the first 9 pupils here are here, and then the 13th pupil is in that group because 9 plus 4 makes 13. So if you line them all up, the 13th pupil is in that group, and the 13th pupil has done 1 hour of work. So the median is 1. And of course, the classic mistake to make there would be not to account for the different numbers of values in each group, and then just kind of take the middle of those and go, oh, well, it's 3.5 because 3.5 is in the middle. And that doesn't account for the fact that you've got different weightings of pupils in the different groups. So I'm going to do what I said I wasn't going to do, which is actually write all the numbers out longhand, just to demonstrate that my answer is correct. So there were 9 pupils that did 0 hours. So if you line all the pupils up, they're saying 0, 0, 0, 0, 0, 0, 0, 0, 0. Then there are 4 pupils who did 1 hour, so if you line them all up, they're going 1, 1, 1, 1. 3 pupils that said 2 hours, so if you line them up, they're saying 2, 2, 2. 2 pupils that said 3 hours, so if you line them up, they're going 3, 3. 4 that did 4, 4, 4, 4, 4. 1 that did 5, 1 that did 6, and 1 that did 7. So they're saying 5, 6, and 7. So if you just kind of cross these off from the ends until you get to the middles, you will find that the middle one is that one there, the last person in the 1 group. Oh, we got one more question. I thought we were at the end. Noah wants to play on a Wheel of Fortune with 8 equally large sections, fields. So all of these 1 to 8 we're assuming are equally likely. The chance that the Wheel of Fortune lands on a yellow is, so you've got 2 out of 8 that it could land on, which is the same as a quarter, or if you like 0.25. Next question. The chance that the Wheel of Fortune lands on a blue field with an even number is what? Okay, so blue ones with even numbers, that's 6 or 8. So there's 2 ways it could land on that out of 8, which is the same as a quarter, or 0.25 again. The chance that the Wheel of Fortune either lands on a field with an even number or a black field, or a black section, is what? Okay, so let's just delete my mess and have a look at that. So either an even number or a black. So that's 2 or 4 or 6 or 8 or the black one. So there's 5 ways that can happen out of 8. And I mean, you can just as well leave that as 5/8 in the answer if you want. That's perfectly acceptable as an answer. 5 divided by 8 happens to be, let's just do this, should be able to do this in my head, shouldn't I? 5 divided by 4 is 2.5, divided by, 5 divided by, 5 divided by 4 is 1.25, and then divide that by 2 again, 0.625, 0.625. Oh, by the way, as a rule, don't ever give an alternative answer like that, because if you give 2 answers that you think are equivalent and one's right and one's wrong, there's a good chance they'll mark you for the wrong one, because otherwise you could just write down kind of loads of numbers and say pick the answer out of that. So don't do that. So I'm going to stick with my 0.625. And we are at the end of the paper.